Okay, folks, let's get into this last problem here and we'll wrap up chapter 7 for the week. Let's see. This, again, this being an algorithmic problem, once you read your problem in the homework, the problem will read exactly like it reads here. The only difference you're going to see is probably in some of these numbers. However, again, I'm going to post this file for you, and you should be able to use this if you want to, or build your own. The setup or the constraints are not going to change in terms of what it is or how it is the problem is constrained, but your numbers will change a bit differently. So let's get into this. La Jolla Beverage Products is considering producing a wine cooler that would be a blend of white wine, a rose wine, and fruit juice. To meet taste specifications, the wine cooler must consist of at least 45% white wine, at least 25% and no more than 35% rose and exactly 25% fruit juice. La Jolla purchases the wine from local wineries and the fruit juice from a processing plant in San Francisco. For the current production period, 10,000 gallons of white wine and 6,500 gallons of rose wine can be purchased. An unlimited amount of fruit juice can be ordered. The cost for the wine are actually for the wines are $1 per gallon for the white and $1.50 per gallon for the rose. The fruit juice can be purchased for 50 cents per gallon. La Jolla Beverage Products can sell all of the wine cooler it can produce for $2.50 per gallon. So let's see. In the end, what we're going to have here is we're going to have a wine cooler that is made up of white, rose, and fruit juice. And so the decision variables will be here: how many gallons of white, how many gallons of rose, how many gallons of fruit juice. So those are the three decision variables that we have here. In the sense of an objective function, this one is a little more complicated than we had before. Think of this as profit equals revenue minus cost. So the profit here will be based on the revenue that is generated from the wine cooler, which is $2.50. And notice that I have that being multiplied times the sum of C3, D3, and E3, because in the end, the wine cooler will be so many gallons, but the number of gallons of the product is effectively the number of gallons of white, rose, and fruit juice. So we'll just take $2.50 times that sum, and that will give us our revenue. And then I have used this sum product function here to compute the cost. And the cost, again, is $1 for each gallon of white, $1.50 for each gallon of rose, and then 50 cents for each gallon of fruit juice. So the sum product of the decision variables times the respective costs will give me the cost of the products that I must purchase here. So again, I'm going to provide this sheet for you. So if you want to just take a look at that formula, but again, remember that this is equal to profit, or profit is the revenue here and then minus the cost. Let's see. So it looks like we've got about 5 or 6 constraints that we want to talk about here. This one may be a little bit more challenging. So what I wanted to do here is I wanted to talk about this first constraint here. It says to meet taste specifications, the wine cooler must consist of at least 45% white wine. And what I have done down here is I have detailed that for you and showed you how I came up with all these crazy coefficients here in this first line. So if I were to write this, algebraically, what I would say is that the total amount of white wine must be at least 45% of the mixture. And that's exactly what this right hand or the right side of this inequality is saying. If I take 45% and I multiply it times white, rose, and fruit added together, that's the total mixture. So this will satisfy the constraint that the amount of white must be at least 45% of the total. Now notice that I've got variables on each side of the inequality here, and I can't do that in Solver. So what I'm going to do is I'm going to expand the right-hand side here, and I'm going to put a 1 in front of the white wine because that's effectively just the variable, and there's one of them. So again, that's just kind of an old algebra trick. But if I expand the right-hand side and I distribute the 0.45, I get 0.45 times white plus 0.45 times rose plus 0.45 times fruit juice. And then if I want to move all of these variables to the left-hand side, I'm effectively subtracting everything on the right. So 1 minus 0.45 is 0.55. There's no rows or fruit juice on the left-hand side, so effectively these become minus 0.45 and minus 0.45 times each of the variables, and then that is greater than or equal to 0. So if I take this and I go over to this first line, that's exactly what I'm seeing here in the coefficients, which matches my math down here. So I have computed that using the sum product, right? This is the constraint for the amount of white wine, the minimum. So I compute that, and that must be greater than or equal to 0 based on the way I've computed this here. And before I had mentioned something about the right-hand side. This is the right terminology based on your book. So the other one is fine as well. Now, if you go through and you read, there's more similar. There's actually a minimum and a maximum. Notice that the signs of the inequalities change to whether you're again talking about a min or a max for the rows, and then you have the fruit juice, which is actually an equality to give you exactly 25%. But if you, as you go through and you write mathematically, you write the constraints for the rows min, the rows max, and the rows fruit juice. Just keep this in mind, and this will get you to exactly the coefficients that I have here. Just remember when you go do your problem, because this is algorithmic, these percentages may be a bit different. The last two constraints here, let's see, there's a maximum amount of white wine available. I think it's 10,000 gallons. It's right here, right? So I have a coefficient of 1 on the white wine. These are 0, and notice I'm computing again a sum product. That's no problem because these coefficients are 0, so effectively the rows and the fruit juice don't play here. So effectively, if I was just looking at this mathematically, this would just be white wine less than or equal to 10,000, and then the same thing here for the rose wine. Since these coefficients are 0 being multiplied by the respective variables, this is effectively saying, or this is effectively going to say that the rows must be less than or equal to 6,500. All right. So let's see. We've translated the written into a linear programming problem, right? We have our decision variables, we have our objective function, and we have our constraints. The final thing here, as we do, let's go to solver. And let's see. Let me set this up from scratch. I had already set this up, but let me set this up. Let me delete or reset all. I think I can do that. All right. So let's do this one from scratch. Let me first make sure I'm using the Simplex LP. Not terribly important right now, but when we start looking at sensitivity analysis, we're going to make sure we want to use the Simplex LP. So where's the objective function? Well, the objective function, we're going to click on D5. We know that we want to maximize our profit. Let's see, what cells are we handing over to Excel to manipulate? It's our decision variables here, and then the constraints. Let's see. Let me. I think since I don't want to change the order on these because I don't want to mess up the video here. But let's see. I think I do these two at the same time. So I'm going to add. Let's see. These two values must be greater than or equal to the corresponding values here. So I have added those two constraints at the same time. This one is less than or equal to, so let me just add that by itself. So I need the computed value will be less than or equal to, let's see, the right-hand side, and that's okay. Let's see, this one's by itself, so we're going to add this, so we'll say that this value must be equal to this value, and we'll say okay. Let's see, and then we've got two constraints here, these maximum amounts of the white and rose, and I think we can add those at one time. So let's add these values, the computed values must be less than or equal to the right-hand side. Now, here's a quick trick. Notice in this LP model, I don't show the non-negativity constraints. The reason I didn't, I just wanted to show here that you can also invoke this non-negativity constraint by checking this or clicking the checkbox here, and that will make sure that the decision variables are both greater than, in fact, actually all three are greater than or equal to 0. So at this point, let's see, we've taken the words, we've put it into algebra, then we've taken the algebra, we've translated it to solver. The last piece here is the fun to just hit the solve button. And let's see, what is it that we've learned? We're going to use, in the optimal solution, 10,000 gallons of white wine, 6,500 gallons of rose wine, 5,500 gallons of fruit juice, and the let's see, the profit here is going to be $32,500. Let's see, I've got a couple seconds left on this video. Let me just go ahead and validate this one constraint here. Remember, the white wine has to be at least 45% of the total mix. So if I look at, let's see, the total mix is, let's see, how many gallons is it? The total number of gallons here is 22,000 gallons, and I've used 10,000 gallons of white. So the number of gallons of white divided by 22,000, this better be better than or larger than 0.45. So let's hope so. And there you have it. Just over 45% of the mixture is, in fact, the white wine. So if you get curious, you can go down and do the same thing on all these other constraints and make sure that you have done what it is that you wanted to achieve here. So, folks, again, I hope these are helpful. Some feedback on how how to improve them or make them a little bit more direct or less direct or whatever needs to be done here. Send me that feedback, and take care and have a great week.